Hello everyone and welcome back. My name is Mr. Kovalt, and in this video I'm going to be going over the classification of matter. In particular, I'm going to go over the classification of matter into based on composition. So you can classify matter based on phase, like liquid, solid, and gas, or plasma. But in this video, I'm going to talk about classifying the matter in terms of composition. So here are some general steps for classifying matter. So to classify a substance, so we're going to classify it in two different ways. So first, we're going to classify it into two categories of either pure substance or as a mixture. And then each of those categories can be further divided, and we'll talk about that in its own. So you can classify or further divide your pure substances into element versus compound. And then you can also classify mixture into homogeneous versus heterogeneous mixture. So we'll get into that too. So here's some general steps for classifying matter. So first, if we're going to classify a substance as a pure substance or as a mixture, then we're going to ask one or both of the following questions. So the first question is, does this substance we're referring to have a constant composition, or is it a variable composition? If it has a constant composition, then that's going to be a pure element. And what we mean by the composition is, what is it made up out of, right? So, for example, water is H2O, and so it only ever has two hydrogens and one oxygen. That is the ratio. It is always that ratio. That is constant, and so therefore water would be a pure substance. Um, and so if it has variable composition, meaning that you can you can vary the amount of the substances, or I would say, if you can vary the amount of the things that it is made up of, or the substances that are made up of, or the atoms it's made up of, then it's going to be a mixture. For example, salt and pepper, right? So I can have a mixture of salt and pepper, and then I can increase the amount of salt, or decrease the amount of pepper, or I could do the opposite, increase the pepper, decrease the salt. It's still a mixture. It doesn't depend on the amount of salt versus the amount of pepper. Whereas water does depend on the composition, right? So if I change the amount of hydrogen in my water, it's no longer water. So in order to be water, it has to have that particular composition of hydrogen and oxygen. So that's the first question. Second question is, can the substance be as a whole described with chemical formula? Can I describe it with a chemical formula or not? If I can, then it's a pure substance, right? So H2O is a chemical formula for water. Na is the chemical symbol for an element, sodium. H2O2 is the chemical formula for hydrogen peroxide, or C6H12O6 is the chemical formula for glucose. And so those are all pure substances because I can give a chemical formula for it. If it's a mixture, I can't really give a chemical formula for a mixture. Like, so if I have salt, which is NaCl, and I have pepper, which is going to be some other formula, right? I can't give a formula for those two as a mixture. It's just I don't have a formula for it, or a single formula for it. They're two separate things that are just kind of physically mixed together. So mixtures are not going to have or be represented by or described by a formula. Okay, so that's the first separation or way of dividing your matter into pure substances versus mixture. Well, what about pure substances? We can further divide up pure substances by asking the following question. So, can it be described with a single symbol, or does it need multiple symbols to describe the substance? So, we're talking about pure substances. So the second question for pure substances was, can the substance be as a whole described with a chemical formula? So yes, if it is a pure substance. So here we're talking about the chemical formula. So if the chemical formula is only made up of one element, right, then we have an element. Pure, simple enough, right? So we have the periodic table of elements. So here I have an example. So on the periodic table of elements, each element has its own symbol, right? So if your substance can be described as a simple one symbol, like in the formula, then it's going to be a an element, right? So if it's not on the periodic table, it's not an element, right? So for example, if it can be described, so we have Na, right? That's sodium. That's the symbol of sodium. So this is an element of Cl2. So it's described as by one symbol, even though it's a molecule. Cl2 has two atoms bonded together. This only has one element, one type of element in the formula. So therefore, it's an element, right? So we can find these elements on the periodic table. If you can't describe it using only one element, or describe it as the single symbol by itself, if you need more than one element in the formula, then that's going to be a compound. That's going to be not an element, but a compound. So that would be things like I said before, H2O or NaCl. These are compounds because you'll notice that the formula has more than one element symbol in the formula. So therefore, it's a compound, not an element. All of these are pure substances because you can represent all of them with a formula, right? This has Na, it's just a symbol for sodium. Cl2 is the formula for chlorine. H2O for water, and NaCl for table salt. So all of them have formulas. These two only have one element symbol in the formula. These two have more than one element symbol in the formula. And so that's how you divide or can distinguish between the element and a compound. The other way also is, can you break it down into simpler substances, right? Sodium, Na, can't break it down into simpler substances because it's only made up of one substance. So that's as simple as it can get. You can't break sodium down further into other substances because it's only made up of sodium. Same thing with chlorine. I can't break that up into something other than chlorine. However, water and NaCl can both be broken up into simpler substances because they are made up of simpler substances, meaning different elements, right? So H2O can be broken up into hydrogen and oxygen elements. NaCl can be broken up into sodium and chlorine elements, right? So that's another way that you can identify element versus compound. So with regard to mixtures, mixtures basically have another division between homogeneous and heterogeneous. Homogeneous mixtures are mixtures that look as if they're not a mixture. It looks like one substance. If you were to look at it, you can't tell it's a mixture. Like take salt water, for example. Salt water is a mixture. It's a variable composition. I can throw more or less salt into the water and dissolve it. It's still salt water. It's still a mixture of salt and water. However, when I look at a glass of salt water, assuming that all the salt has been dissolved, you wouldn't be able to tell. You would just look like water. When you drink it and taste it, you would then be able to tell. But by looking at it, it would look like water. It would look like one thing, one substance, right? So that's usually the way that you would determine a mixture as a homogeneous mixture. If it's a heterogeneous mixture, then when you look at it, it is obvious to your senses that it is a mixture. Like take chocolate cake or a chocolate chip cookie or spaghetti or a salad or anything like that. You look at it and it's obviously made up of different substances, different things together, right? So if you look at a metal, right? If you look at steel, or if you look at bronze or brass or something like that, it looks like one substance, even though it's a mixture of different metals together, right? So that is the way you would define or determine or describe um, whether something is a homogeneous mixture or a heterogeneous mixture. Okay, so in the next part of this video, I'm going to go over and then I'm going to draw out a flow chart that might help visualize this better. Okay, so here I have a flow chart that might be helpful in understanding how to classify matter into its different categories. So again, you start with matter, and the questions that we begin with is, does it have a constant composition, or can it be described with a chemical formula? Those are kind of two different questions that are getting to the same thing. So if yes, it does have a constant composition, meaning that the what the substance is composed of or made out of doesn't really change, the ratio or the amounts of those substances don't change, then you have a pure substance, right? If you can change the composition and still have that same thing, right? You can mix different amounts of it together or put different amounts of the two substances or whatever substances together, and you still have that substance. It's going to be a mixture, right? So salt and pepper mixed together, I can add I can add more salt or add more pepper, and it's still a mixture. Okay. Um, then on the pure substance side, right, again, with regard to the chemical formula, pure substances can be identified or described with one single chemical formula. And the formula shows you the ratio or the amount of each substance that particular substance must have. Like, so for example, H2O must have two hydrogens and one oxygen. For every one oxygen, it has to have two hydrogens bonded together. And so that is what makes water water. If you have H2O2, two oxygens with two hydrogens, then that's not going to be water, right? So it's a pure substance. It's identified with a single formula. Now, the next question you want to ask yourself for the pure substances, in order to divide this into element versus compound, can it be broken down into simpler substances? Can you break it down into elements, basically, is what it's asking. Or can it be described with a single symbol, like an elemental symbol, right? So if yes, then it is an element, right? So sodium, Na, calcium, Cl2, N2. Notice that these are molecules, but they're elements because they only have one type of symbol, the element symbol of chlorine versus the element symbol of nitrogen, nothing else. So these cannot be broken down into simpler substances because they're as simple as they can get. Okay. If you can break it down into simpler substances, or if the formula requires more than one element symbol, then it's a compound. So H2O has hydrogen and oxygen in the formula. And notice it's always two hydrogen, one oxygen for water. NaCl, you got sodium and chlorine. For glucose, it's carbon, hydrogen, oxygen in this ratio, 6-12-6. So that is what makes that glucose. And so these are all compounds. For mixtures, the question is it uniform throughout? In other words, does it look like one substance or not? So if you look at it and it looks like one substance, then it is going to be a homogeneous mixture. So let me write that down. So this is going to be homogeneous. I'll write it here. Homogeneous. And here it would be heterogeneous. I'll just write hetero. So if it does look like one substance, then it's a homogeneous mixture. So for example, my saltwater example, apple juice assuming there's no pulp in the apple juice, right? When you look at apple juice, it just looks like water with a color added to it, clear water. Brass looks like one substance, even though it's a mixture of different metals together. Coffee, if we're talking about black coffee, or with sugar and cream mixed in uniformly, meaning that just you can't tell if there's added to it or not. And then Kool-Aid, right? Just looks like colored water. Looks like one thing. But when you look at it, it's obvious that it's more than one thing. That we call that a heterogeneous mixture. Homo meaning the same, right? Same kind, looks the same throughout. Hetero means different, looks different throughout. Like, so for example, pizza. Obviously, when you look at a pizza, it's a mixture of different things together. A salad, a birthday cake. So all of those, when you look at them, it's obvious that they are mixtures of things. And so that, ladies and gentlemen, is how you classify matter into its different categories based on composition. So I hope this was a helpful video. If you enjoyed this video, if this helped you in any way, then please like the video, share the video, hit that like button. Also, make sure that you subscribe to my channel, hit that notification bell. When you do, make sure that you click all so you can be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a topic you want me to cover, or if you have a particular problem or a question you want me to answer, I would love to do that for you. Please have a good day, have a good night, and I'll see you again